We want to look at limit of functions under differentiation. Now, we have several types of functions that have to be treated with different rules. I think we have like 6 types. We are taking the first type at step 1. We have limit or function of x, limit of function of x as x tends to c. Now we are going to write that limit of function of x as x tends to c is a constant. It's a constant provided that function of x is also a constant. Function of x is a constant. Then limit of function of x as x tends to c is also a constant. That is, limit of function of x as x tends to c is a constant if function of x is a constant. Now, interpreting that language, let's take like one example here. Example 1. If we have limit of 4 as x tends to 2. Now we can see that this is function of x, which is 4. 4 is a constant. Now as x tends to 2, it does not affect the value. The answer will still be what? 4. That limit of function of x as x tends to 2, if function of x is a constant, will also be what? That constant, which is 4. So that is it. If we take another example to buttress that point, we have limit of 2 over 3 as x tends to 3. Now it will become 2 over 3 because this is a constant, so this cannot affect the answer. That is the first type of limit of functions. Now we can move further to the second type. Now for the second type of limit of functions, let's call it B. Now we may have limit of function of x, limit function of x as x tends to c. Continue to use c. You can use a, you can use b, or any other variable, but like using c. So limit of function of x as x tends to c will be equal to c, provided that function of x is equal to x. So if the function of x is equal to x, the limit of function of x as x tends to c will be equal to c. Now, take an example under that. Now, let's take one example or two. Now, if we have limit of x as x tends to 5 will be equal to 5 because it is limit of x. So whatever this tends to, that will be the limit of the function because the function of x here is equal to x. The function of x is equal to x. So the limit of function of x as x tends to 5 will always be 5. Now we can take another example. There's a limit of x as x tends to 6. Obtain the limit of x as x tends to 6. It's obvious that the function of x here is x. Now that is function of x here is x. Now as x tends to 6, the limit will also be equal to what? 6. So that is the limit rule. Now we have another type. We have like 6 or 7 types. Now let's take number 3. That one is when we try to sum 2 or more limit functions. So if we have limit, that's limit f of x as x tends to c plus limit f of x, let's take g of x as another function as x tends to c. That will add up to limit f of x plus g of x as x tends to c. So we just add up the functions and get our answer. Alternatively, if we say if lim f of x, if limit of function of x as x tends to c is m, and limit g of x as x tends to c is equal to n, then the addition of the two limits, lim f of x plus limit g of x, as they both tend to c, as x tends to c here and as x tends to c here, will just be m plus n. So this is one version, and this is another version. So we can consider the two and see arrive at the same result. Now, applying this rule, we can solve some problems. Now, let's take problem 1. Now, we have limits of x plus 4 as x tends to 3 plus limit 2x minus 1 as x tends to 3. All that we have to do is we solve this one, whatever it gives us. That is, we have the function of x here is x plus 4. The function of x here is 2x minus 1. So 3 will take the place of x. That is 3 plus 4, that is 7. Then plus. What do we have here? 3 times 2, that is 6 minus 1, 5. So we have 12. So that is the answer. The answer there is 12. The answer there is 12. We just obtain the limit of this and obtain the limit of this with reference to 3, 3. Then we add up the answers. Alternatively, you can just say, okay, or we say limit as x tends to 3 of x plus 4, then in the bracket, make this a square bracket, then plus 2x minus 1. Now, by expansion, we have limit x plus 2x, that's 3x, 4 minus 1, that's 3, then as x tends to 3. So 3x is 9 plus 3, so we have 12. So the two rules can be applied and we get the same thing. Now the last that we are going to consider under this part is condition 4. We have another condition where that is, I call it D, that's condition 4. If we have a limit of a constant into function of x as x tends to c, then in that case we have limit of function of s. A constant is multiplying the function of x there, and the constant there is m. Is the constant multiplying the function of x. We can easily bring it out and say m means f of x as x tends to c. X tends to c. So bring the constant out to multiply whatever we get here. Now, taking an example under that, we have to obtain the limit of this function. Example A, we have a function, limit of function 3 into 2x minus 1 as x tends to 2. We simply have 3 limits, 2x minus 1 as x tends to 2. Now, under that situation, we have 3 times limit of 2x minus 1 as x tends to 2 is 2 times 2, 4. 4 minus 1, 3. 3 times 3, we have 9. So the answer is 9. Alternatively, we can just expand this. 3 times 2x, that is we have limit of 6x minus 3 as x tends to 2. So that gives us 6x, that's 6 times 2, which is 12, and minus 3, and that still gives us what? 9. This is the conclusion of part 1. We'll continue with part 2 immediately after this class. Thank you very much. I wish you all the best.